Good morning, everyone. This is Payavala Bhavgna from Institute of Aeronautical Engineering, IARE. I'm from the branch Computer Science and Engineering from Section A, and my roll number is 24951 A0559. And today I'm here to explain a topic called Recurrent Path Index for Efficient Graph Traversal in Python for Tech Talks um, from the subject Essential of Problem Solving. Now, let us dive into the introduction. Now, as we all know, introduction to graph traversal. Graph traversal is a fundamental operation in many computer science applications. Efficient traversal techniques are essential for optimizing performance in large scale data processing. This presentation will cover the recurrent path index and its implementation in Python. Now, as we can see in the diagram here, these spherical structures are known as either vertices or nodes, and the lines joining these are known as edges. Now here 0 is connected with 1 and 2, meaning it has two edges, which sums up the 0 node has two edges, and the 1 node has three edges, and the 2 node also has three edges. Then 5 has only one edge and 6 has only one edge. Same goes with 3 and 4. So this is how the graph traversal works in Python. Now let us get to know about the actual meaning of a graph. Now a graph consists of nodes, which are also known as vertices, connected by edges. Graphs can be directed or undirected, impacting traversal strategies. They are widely used in various domains, including social networks, transportation, and web link structures. Importance of efficient traversal. Efficient graph traversal reduces the time complexity of algorithm significantly. It is crucial for applications such as search engines and recommendation systems. Optimized traversal techniques can handle uh, larger data sets with better performance. Now, here, as we see in this picture, tree traversal algorithm contains in-order traversal, pre-order traversal, and a post-order traversal. Let us get the overview of traversal algorithms now. Common graph traversal algorithms include depth first search (DFS) and breadth first search (BFS). Each algorithm has its strength and weakness depending on the graph structure. Understanding these algorithms is pivotal for implementing advanced techniques like the recurrent path index. Now, as we can see here, BFS starting from node 0 in this graph, and 0, 2, 1, 3, 4, 5 is the order. Limitations of traditional traversal. Traditional traversal method often struggles with complex graphs and large database. They may lead to excessive computational overhead and inefficient memory usage. This necessity and development of advanced indexing techniques for better performance. Now let us get to know about the recurrent path index. Starting with the introduction, the recurrent path index is designed to enhance graph traversal efficiency. So mainly, it pre-computes paths to minimize uh, redundant calculations during traversal. This indexing technique significantly speeds up query response times. How recurrent path index works. The index captures recurrent paths in the graph to avoid recalculating them. By storing these paths, the traversal algorithms can access them directly. This leads to a more streamlined and faster traversal process. Recurrent neutral networks. Now, this is the blue thing is the input net layer, and the hidden layer is the pink one, and the output layer is green one. And recurrent neutral network. Key components of recurrent path index. The index consists of data structures that stores paths, nodes, and edges. It utilizes hashing techniques to optimize lookups and retrieval of paths. The design ensures minimal overhead while maintaining high retrieval speeds. Data structures used. Common data structures for implementing the recurrent path index include dictionaries and lists. Graph representations like adjacency lists or matrices can also be utilized, but the choice of data structure impacts the efficiency of path storage and retrieval. Now, here in this, we have an example that A is the array name and the elements are here for example, here the elements are 15, 26, 5, 66, 7, etc. And the index starts from 0 basically, and it extended up to 9. So the overall size sums up to 10 including the 0. Implementation in Python. Python provides versatile tools for implementing the recurrent path index. Libraries like NetworkX simplify graph like manipulation and traversal tasks. Custom classes can be created to encapsulate the indexing logic for better modularity. Sample graph creation. To demonstrate, we first create a sample graph using NetworkX. The graph can be populated with nodes and edges representing real-world data. This serves as the foundation for applying the recurrent path index. Here we have a complete graph without any cutting, which consists of nodes and edges, and which is complete. This is basically considered as a foundation for applying the recurrent path index. Building the recurrent path index. Now, how to build this recurrent path index? This process begins by identifying recurrent paths within the graph. Like you need to identify the recurrent paths after drawing a graph. Each unique path is stored in index for fast access during traversal. The building phase is crucial for optimizing future queries. Querying the index. Once the index is built, querying becomes straightforward and efficient. Users can retrieve paths with a minimal computational cost. This allows for rapid responses even in large graphs. Leveraging GraphQL for efficient data querying and manipulation in modern web applications, said by Cron J. Performance benchmarking. Benchmarking helps access the efficiency of the recurrent path index. Comparisons with traditional traversal methods with highlight performance gains. Results typically show reduced time complexity for path queries. Now here we have an analysis of environmental management cost. Use cases and applications. Now the recurrent path index is applicable in various fields such as social network analysis. It is also beneficial in GIS applications for route optimization. Industries like finance utilizes this technique for transaction analysis. Now use cases and applications of GPT-3 in the real world. Challenges and consideration. Despite its advantages, implementing the recurrent path index presents challenges. Now, these are like careful consideration of graph structure is essential to maximize efficiency. So, you need to reconsider and check it again just in case. Maintaining the index with dynamic graph requires additional strategies. Future directions. Ongoing research aims to enhance the recurrent path index for even greater efficiency. Integration with machine learning techniques could further improve performance. Future development may focus on adaptive indexing of dynamic database. Now, the cycle goes like identify, analyze, then plan it, then implement it, then reflect, then repeat. Now, let us come to a conclusion, which is the recurrent path index represents a significant advancement in graph traversal. Its implementation in Python offers a practical solution for developers Embracing such techniques can lead to sustainable performance improvement.